Hello everyone and welcome back again. In this lesson we're gonna explore how to utilize other techniques or other ways in order to draw certain objects or in order to render certain objects in OpenGL. Now, in order to see how these stuff actually been done, you can see in the well, generally we have been using GL quads. We have used, I believe, GL triangles at certain point. So let's see here. So let me hit Control F5 to show you the latest progress which we had made since the last lesson. So we had this rotating cube face, in fact, not cube. So rotating face, which is like have these two vertices keep flashing or keep changing colors. So we utilize something which is called GL quads. Now there are other ways of drawing, or there are other utilities we use to draw, and let me show you the drawing modes. In here you can actually draw points in OpenGL, you can draw lines, and we're gonna see what is lines, line strip, line loop, the difference between them. We have triangle fan, triangles, we have been using this one, and GL quads we already utilizing this one, so in the code as you can see here, and triangle strip. Okay, and visually it is quite, you can perceive it from, when you can get clues actually from seeing these how these stuff actually being laid out. In GL points you are literally drawing actual points. I believe the minimum point is gonna be like somewhat like a pixel size or something like that, and of course we can even expand it, make it a little bit bigger or so. This is and this could be easily it's quite easy to achieve, and as I'm gonna show you in a second. Geo lines, so basically, geo points, you basically call geo vertex, and you specify the coordinates. And if you have your drawing mode as geo points, you're gonna get that vertex drawn or rendered in the in your scene as a point, like in your scene. The many you specify, the more points you get. Geo lines, however, you specify 2 points, at least 2 points, in order to get one segment or one line segment. Okay, so if you say geo lines and you passed in 4 vertices, OpenGL automatic will grab the first geo vertex calls and it will immediately make a line out of it. The second 2 geo vertex calls and it will immediately make a line segment out of it. So at the end you're gonna get so at the end you need to describe for describing a line using GL lines, you have to at least pass in 2 vertices. In this case, using this method, using GL lines, you can actually specify a line loop. You can specify if you need, for example, to specify 2 lines, you need to pass in 4 vertices. Okay, that in case if you would like to make 2 lines using GL lines. GL line strip, however, if you pass in the first 2 vertices, it will make 1 line segment. If you pass the third, it will immediately reuse the last, or the GL vertex before the last one, and it will make out a line segment. So technically speaking, if you give the computer, or if you give OpenGL like 2 vertices, it will make a line. Making the third one, it will immediately use the last one and connect that vertex to the last one which you passed in, and so on and so forth. Now this is quite actually cool, because right now the amount of GL calls has been minimized. Now I can, for example, pass in 3 vertices instead of 4 in order to describe 2 line segments. Now of course it's up to you how this stuff has been done. Because sometimes you would like to draw only separate line segments, so it's up to you whether to use line strip or line loop and so on and so forth. So basically, using line strip, right now you minimize the number of GL vertex calls to 1. GL line loop, however, is the same exact idea as the GL line strip, except just the last vertex, once you describe it or once you specify it, OpenGL will immediately, once you run your application, it will immediately make up a line which takes the last vertex, connects it with the first one. So at the end you're gonna get a closed shape, or may or have a line loop, as you can see here. Okay, so this is the Geo line loop. Geo triangle fan is basically almost the same thing as Geo triangles, except it just being drawn from the center. And let me tell you what I'm talking about here. So basically, if you specify a vertex, so let's say this is the first one, and you specify other two, basically in order to describe a triangle you need minimum 3 vertices. Okay, so any triangle you would like to describe, you need at least 3 points, so 3 vertices. Now once you specify the first triangle, once you add the second one, you immediately share 2 vertices, and you get immediately one more additional triangle. So basically, in order to describe a triangle like using the classic way, you just specify, if you would like to specify 2 triangles, then you need to pass in 6 vertices. I could specify here 2 triangles using Geo triangle fan, and I could pass only 4 vertices. Okay, so right now I minimized my Geo call by 2. So right now I subtracted, or I did, or I take away, or took away 2 Geo vertex calls, and I got this almost the same result. I got actually 2 triangles rendered in my scene. Now how they are rendered and these and so on, this is actually up to you. But again, I'm not saying that the Geo triangle fan is better than Geo triangles or something like that. All these are drawing modes. Each one of them could be utilized differently. Just you have to understand the difference. So I wouldn't say right now that this one is bad and this one is good. This is just simply what kind of result you're gonna get, and what you get as well along with that result. Less OpenGL calls, more GL calls, and so on and so forth. Okay. Now this is for triangle fan. Of course, when you start adding one more vertex every time, you get every time one more triangle. So at the end you're gonna end up with something like, you know, rounded shape, if you will, or something like that with Geo triangle fan. Geo triangles, as we already mentioned, you need to pass at least 3 vertices in order to make a triangle. If you would like to make up another one, you have to pass 3 more vertices in order to have one more triangle. Geo quads, on the other hand, is like the one which we have used. You have to pass at least 4 vertices in order to get a face. You see, it's quad from its name. I mean, you have to pass in 4 points in order to make out a polygon. Okay, and of course, the more you have to add 4 more in order, for example, to get, like, you know, another one, or probably you can even add 1 more and see what's going to happen. Probably you need at least 4, I believe. For Geo triangle strip, is almost the same thing as triangle fan, but it's much better. You can right now not only draw some sort of, like, you know, you are not fanning out from the center, but in fact you can describe a surface using only triangles. And of course it has the same idea. You specify 2 vertices, or excuse me 3 vertices, and you get a triangle. The more you add, the more triangles you get. So you could, for example, have at the end 2 or 3 or 4 triangles for much less much less vertices or Geo calls than the Geo triangles over here. Okay. Now, of course, feel free to try them out all. You know, like, experiment with them, try to get comfortable with them. In my case, right now, I'm gonna show you how to draw Geopoints and Geo Lines and line strip, probably in line loop as well. It depends, because and this lesson objective is I'm gonna show you how to I'm gonna show you how to draw points and everything, probably control the sizes, and afterwards I am going to show you a very easy way to draw a circle in OpenGL, and then probably draw a waveform or sinusoidal kind of waveform in OpenGL. Okay, so let's get back to the code so we understand already the drawing modes we have here. So I am gonna looking at this code, I'm going actually to well, what to do now. It's like, okay, I'm gonna yank out this, just simply go away. Alright, and I'm gonna even take out this one too. So we have a nice clean sheet. And in fact, I'm gonna leave this right there. I will not touch it. Okay, so okay, I could, okay, it will pass. Anyway, probably I'm gonna even comment those and comment those as well. Okay, because it doesn't matter whether I go forward or backwards, because right now I'm gonna show you how to draw a GL point. So gl.gl begin, um, gl begin, and in the drawing mode, gl underscore points, and gl.gl end. Now in here I'm gonna call a small gl, or let us say, okay, let us say gl color for now, color 3D. I'm gonna pass in 111. Oops, sorry, 111. And gl vertex 2D. I mean 2D is gonna be fine, and I'm gonna leave it at the origin for now. Of course, you can specify gl vertex 3D, and it will not. But I mean, for now, I would like you just to see it. So I'm gonna hit Control F5, and hopefully, I hope that you can actually notice from the video that you see that tiny teeny point, that pixel size point. You can see it. As you can see here, I've described a color 1111. So hopefully with the compression of the video, you can see actually that point. So what if I would like to make this point bigger? If you would like to do so, I could go here in the set attributes and start enabling certain switches in OpenGL. So I can say gl.gl point, sorry, hang on a second, enable. First of all, I have to enable certain stuff. So enable the switch of gl underscore point underscore size, I believe. There you go. And gl.gl point size. And here you can pass in whatever point size you like. I could, for example, pass in 10. Okay, so this is my point size. Now if I go back here, this one is going to be called automatically, by the way. So it's going to be, this one is going to be this switch is going to be enabled, and I'm going to hit Control 5 and bring this over. Now of course you're going to get this magnified, like, huge pixel or huge point. Now of course, as you can see here, it's square. And please do not think that you can actually rotate, or you can use it as a plane, because you cannot rotate around it. It's a point. It's gonna face you all the time in your face. I mean, it's gonna just face you. Okay, so you cannot. I mean, you will not rotate around it unless it is positioned in 3D space, and then you're gonna. And if you have other several points, now you can see how other points move relatively to the other ones once you are rotating in 3D space. But otherwise, right now, if I rotate around this one, you will not feel anything. So some people will say, okay, how can I, for example, make it, instead of, like, square, I like points, usually round points. I would like to have circle, and it is not a replacement for the circle, please. So please remember that. So gl enable gl underscore point smooth. There you go. And Control F5. Control F5, and as you can see here, I got a circle. Let me magnify this. Let me make this 30. Now that's a huge point right there. And as you can see here, I get, like, nice circular shape. This is how to draw a point. Now of course you can specify even more. I could, for example, put here along the y-axis, so above it I'm gonna add just 0.5 probably, or 0.2. I'll be 0.5. Yeah, I'm gonna just leave it like so. Let's hit Control F5. So there you go, I've got 2 points, and you just can have fun with it. You can actually try to experiment with these stuff. You can get other interesting, like, you can form up other interesting shapes using the techniques which I'm gonna show you right now. So this is how to draw OpenGL points. Okay, so let me delete those, And let me go over here and switch right now from Geopoints. So I'm gonna leave this as okay, so it's gonna be drawn right now. I'm gonna actually switch to GL_lines, and I'm gonna draw a line, single line segment, and you can even have fun with it. Like I could specify each vertex a different color, and you can get interesting effects like this one: 0, comma 0, will it be red? And Control F5, and as you can see here, I got an interesting gradient going from white to red, and this is one line segment. Okay, you can we can put it out like 1 and 1, and probably the other one is going to be -1 and -1, so it will run diagonally or across the screen. So there you go, here's our line, and of course you can rotate around it. I believe let me do it like this. Let me uncomment those two, and hopefully, okay, I'm gonna assign 2 more keys over here just for the sake of demonstration here, just to show you how this happening. So WASD, we got it for okay, I'm gonna put Q as rotate Y plus equals 1 and break. Hang on, semicolon, keys dot we have Q, and I'm gonna use E in this case, and I'm gonna use this as rotate Y minus equals 1. Alright, and break. Okay, now we have rotate Y is already in there. Now I'm gonna hit Control F5, and after give it a second, there you go. So right now I'm gonna hit Q. As you can see here, I'm rotating around the Y axis, and right now the line is just simply rotating with me along. Rotate it back. Okay, so this is one of the benefits of getting you know, line segments and seeing them while being rotated. So there you go. Okay, let me close this. This is actually for lines. Line loop is the same thing. You're gonna just simply add one more vertex. So basically, I'm gonna have GL color 3D, and here I'm gonna add in a green one, and I'm going to have a line that is -1 in X and 1 in Y, let's say. So we're gonna have some sort of kind of number 7 shape or something like that. Or not. Hang on a second, let me have a look at the... Oh yes, I forgot to change the drawing mode, loop or line strip. Let me show you the strip one first. Control F5. And we got some sort of like number 7 shape. Okay, so 3 vertices and you get 2 lines. If I describe a line loop, oops, I probably... Oh yeah, I didn't close the application apparently. Okay, Control F5 right now. And as you can see here, I got some sort of triangle right away. Just outlined, of course, triangle. As you can see here, I can rotate it. Okay, kind of interesting. Now, this is for some of the drawing modes, of course. And in order not to probe every one of them, I mean, you can guys try for yourselves these things. Let us have fun more, and let's try, for example, to construct something much more interesting. Let's try to draw a circle. Now, in order to draw a circle, I'm gonna add one more class. Okay. And in here, I'm gonna have, in my class, I'm gonna call this circle. And probably I'm gonna make it public. Doesn't matter. Probably you could make it not public. It's up to you. I'm gonna have a public double radius. So every circle has a radius. And we're gonna get and set public double, and then number of points. Okay, and you have to try to understand that OpenGL doesn't rasterize anything that it is not straight line, if you will. So basically you are building up how can I say, geometry, or you're building up geometry out of many smaller straight lines when you are trying to draw, for example, a curve of some sort. So for example, in order to describe a circle, you have to add, you have to, for example, specify at least, let's say, 25 to 30 points in order to draw a line segments between these points. And the more points you have, the more smaller line segments, the more the smoother the circle. And we're gonna see in a second what I'm talking about here. I'm gonna make a public constructor. The default one, I'm gonna have a very simple radius, so this dot radius equals to 1, and this dot number of points is going to equal to, let's say, 24. This is the default one. For the full constructor, probably you're going to need it one day. I'm going to have double radius, double number of points, and yeah, probably this is it. In case we would like to make an ellipse out of it, we're gonna see in a second. And in here, I'm gonna have this dot radius equals to radius, and this dot number of points equals to number. Let me make this smaller, and I mean it doesn't matter for you guys, but just I'm just writing it like so, just in order not to confuse you. So number of points. Now, off to draw the circle. So, public void draw circle. Now, in order to draw a circle, let me try to grab probably paint, and let's make it smaller to fit in the screen. And I'm gonna hold shift to draw one circle, and let me like draw hypothetically a line that passes through the center almost. Okay, now let me grab something that could be visible a little bit. Yeah, I'm gonna grab red. Yeah, it's obvious here. So basically, my circle is gonna be composed of several of these points. I mean, it's not going to be composed of several points, it's going to be composed of several line segments connected between those points. So the more I specify, the more line segments I specify or add, the better the quality I'm going to get out of a circle here. Okay, so basically this is it. Like, and then it goes, of course it goes like all over the way over here. Now, in order to specify where these points are on the circle, now there are a lot of ways, or several ways. You have the equation of the circle and everything you can actually probably use, try to figure out a way of drawing a circle. By the way, this is not the only way of drawing a circle. There are algorithms existing for that. I'm going to show you the most simple, of course, and of course it is, since it's very simple, it's completely inefficient, what you're going to see right now. And I'm going to tell you why in a second, once we finish writing up the code. But I'm going to show as well one efficient way I found over the internet that's quite interesting. But okay, let me first draw this. So basically, in order to find a point in that circle, I'm going to like draw a line over here. And as you can see here, this is my radius, which is known to us. I mean, the user has to pass in the radius. This is what we call a right triangle. Okay, so this angle is 90 degrees. This theta angle is known to me. Okay, we're gonna even calculate it in a second. So this is theta, and this is x, and this is y. Now, in order to find, now if I ask you, let us try to find that point. you have to you have to know how much in X you have to move in here and how much in Y you have to move up. So from the trig course in high school, you can we can specify X as cosine, sorry about that, so cosine of the angle, so of theta. I'm gonna just put theta over here. Again, guys, I'm using the mouse, so bear with me. And multiply it by the radius. Y on the other half, or in the other hand, is gonna be sine of theta multiplied by r. Okay, so it's really quite easy. This is it. This is one way. There you go. This is one way to specify where a point is on a circle. Now, if I have a for loop going, I can just simply like generate these points and just simply call the geo line loop, geo vertex, just to draw these line loops, and this is it. It's really quite straightforward. There's one more formula we're gonna have to use. We have to specify how much. Oops, sorry. Hang on. Let me do it like this. So how much angle we're gonna pass in? I mean, how much? What is the angle in this part? Because I'm gonna need it in order to increment or in order to move these two guys. Okay, so let me minimize this and let me show what I'm talking about here. So I'm gonna make a small, let me first put here the using. Now, many people could probably notice that I shouldn't do so, but this is like just for beginning, probably because basically the circle's responsibility, if we're talking about software engineering basics, circle's responsibility is not to be drawn here. It's actually the job of the renderer. You have to generate some sort of like array of these points or these lines, and then you give it to the renderer, and the renderer renders it, and the renderer renders it. Okay, but basically for now I'm gonna keep everything in the same class, so it's gonna be easier for you guys to follow along. Now, I'm gonna have a for loop here, or geo.gl begin first. I'm gonna start drawing geo.gl underscore line. I'm gonna call it line. Yeah, why not? Line loop. There you go. Geo.gl end. And okay, it's fine. Now I'm gonna specify double angle equals to, or first of all, let's do our for loop. So for double d equals to 0, and that d is less than or equals this the number of points, d plus plus. I'm gonna shift tab this one for organizational purposes. And right now, so basically between the GL begin and GL end, I will just simply like generate those vertices, but I have first to construct my formulas first. So in order to specify the angle, now in order to know how many points I'm going to arrange around my circle, I'm going to take because I'm going to multiply, because basically hang on a second, basically a circle is 2 pi, so 180 plus 180, so 2 pi. Okay, and I'm going to divide it by the number of points, so number of points, so NP, let's say for now, so NP. So I'm going to divide it by number of points. Right now I get like how many increments I'm going to get this distance. Okay, this is actually my angle. Okay, I'm going to get the exact angle. Now in order to shift it every time from here to here to there, I'm going to multiply the whole thing by my d, which is I get from here. Okay, so d multiplied by 2 times math.pi divided by this dot number of points double x equals 2. In here I'm gonna just specify, I'm just gonna use this formula, cosine theta multiplied by r. So I'm gonna have here math dot cosine the angle, this one, so cosine my angle, multiplied by the this dot radius, double y equals to math dot sine of my angle, and multiplied by this dot radius. Okay, now here of course I could call, or I have to in fact call geo vertex. I'm gonna specify it here 3D. If you would like to, you can specify 2D, it doesn't matter. I'm gonna pass in x, y, and 0. Okay, so every point which I've got, so x and y, and 0 for z, because my circle is drawn on a single plane, right? If you would like, probably I'm gonna in any future point you could like, for example, to add like to control certain points where they are positioned in z-axis. Probably you're gonna make like sort of twisted kind of circle if you want to. Okay, now let me go here into the main, my main form. I am going to specify here, let me take out this glow thing as well, it's not needed anymore, and I'm gonna specify here circle, and once the main form has been created, please create for me a new circle. So circle equals to new, and in this case I'm gonna use the default constructor for now, and over here I'm gonna delete this. I don't need this anymore, hopefully. Delete. And circle dot draw circle. There you go. And Control F5. And as you can see here, I've got nice circle laid out for me. So there you go. I'm rotating it. So this is our circle. Now, if you notice, if you look at it carefully, let me just Control F5 that. You see how, I mean, right now I passed in 24 segments by default. It is in the default constructor, and as you can see here, I got like kind of a choppy or not that perfect circle. If you'd like to add more to it, I could even modify the constructor a little bit, or modify the properties. It's up to you. I'm gonna here pass in the radius. I'm gonna leave it at 1 for now. A number of points instead of 24, I'm gonna pass in 50. Control F5, and I have got here much better circle. Okay, now the problem with this code, it is really inefficient, because the trigonometric function calls for the CPU are actually quite expensive, and you are calculating this really a lot when you are drawing. So it's better to be pre-computed before you actually start drawing. But this is completely, it's going to be completely another topic. Probably I'm going to show to you in a different class how to draw even much more efficient circle, numerically stable. I'm going to actually grab from my probably grab from my clipboard, or let it be in the next lesson. I'm going to explain it to you in detail how to draw even much more efficient circle, probably in the next or the lesson after. Okay, but basically this is a very simple way to draw a circle. If you would like to get an ellipse out of this, if you would like to have not perfect circle but ellipse, you can multiply this piece by, let's say, okay, for the width I'm gonna have, this is the width, I'm gonna have 5. For the height I'm gonna have 4. So Control F5 this, and nothing. Hang on a second, let me have a look of what's happening over here. Hopefully I haven't yanked out anything. Okay, let me try to take out these numbers again, although it was, and I'm playing with it, was working. Okay, we have a circle. Now once I try to okay, let me try to put this 5, try to put this 4, and hopefully let's see what's gonna happen if I finish this like so. Probably it's gonna make a difference. Or am I missing something? I mean, it should work in all cases, but yeah, somehow the line loops is not okay. Let me see. Oh, I mean, it should work. Control F5 again. I'm trying to hit S to get away. Oh, there you go. Here is it. Apparently it was too big to be rendered. I was worried for a second here. Well, anyway, this is it. So you have an ellipse, okay? And of course you can replace these by variables like public double width get set, public double height get set, okay, and replace those. So this is gonna be this dot width, and this is gonna be this dot height. All right. Okay, so now we have got this. You could actually start modifying the circle, how it's being drawn and everything in the properties here. Now, of course, please do not forget to put this in the default constructor to be this dot width equal to 1 and this dot height equals to 1, because in case if you got a 0, the whole thing will be always resolved to 0, so please take care of that. And here as well, I'm gonna even copy those two lines, paste them right here, because I'm too lazy actually to modify the constructor right now. So basically this is it. So this is how to draw a a circle, or in our case an ellipse. Alright, so what else we could do? You could in fact draw even a different kind of forms. Like right now, if I utilize this technique, like using a for loop, and then you can just simply start generating points based on certain like equations or certain stuff. Right now I could have fun with it. I could even like add one more class, and I'm gonna actually render here a wave. So if you would like to have a waveform, this is it. Now before I actually go and start working on a wave, let me hit Control N. No. And we have to understand a couple properties, small tiny properties of the wave, how they actually work. Okay, so basically, I don't know, what is this? Oh, okay. Well, okay, it doesn't matter. I'm gonna grab the brush over here, and again, please bear with me. I know it's gonna look ugly, but you're gonna get the idea. All right. When you look at a wave, wave has an amplitude. So this is called amplitude. So the amp for now, in order not to draw awkward letters using the mouse over notepad. So this is gonna be the amplitude. You have a frequency. So this is the frequency. I'm gonna just call it fric. And as well, one of the other properties that you can have, or you could just simply like push in our class, is the phase, which is the calculating the angle of the difference of how much two waves has been shifted away from each other. And let me show you what I'm talking about here. How I'm gonna show you how they look like once I include the phase into the equation. So basically, okay, let me just minimize it in case I need it again. I'm gonna have a public double amplitude get and set, public double frequency get and set, public double phase get and set, and I'm gonna have here public wave default constructor. and I'm gonna have here this dot amplitude for now is gonna equal to 1. This dot frequency I'm gonna leave it to 1000, and this dot phase I'm gonna leave it as 100. Okay, or probably 1, it's up to you guys. Another constructor, public wave, and in here I can pass in the amplitude double frequency and double phase, and of course let me just copy this, paste it right there, and in here I'm gonna have amplitude, frequency, and phase. And right now let's try to draw the wave. So public void draw wave. Now the formula for drawing the wave is the following. So basically I have first to import or to use tau OpenGL, and in here I'm gonna have gl.gl begin, and I'm gonna call it gl.gl underscore line strip this time, because I cannot have a wave that's wrapping around itself. End, and gl end over here, and for double d equals to 0 and d is less than or equal 100, so I'm gonna go for 100 iterations. You could even include how much you would like to iterate, so it's up to you as well. Plus equal 01. Okay, shift tab for this guy. Now again, you could specify a number of iterations, how much this frequency lasts, so it's up to you guys. You can actually put it right there. So here I'm gonna specify double y because we're gonna move along the y-axis. Okay, oh excuse me, we're gonna move along the x-axis. We need just to specify how the up and down will look like, because the frequency will go up and down, so we need to specify how y will look like. For this dot amplitude is gonna be multiplied by math.sine, and this is gonna be multiplied by d. So inside this sign is gonna be d multiplied by the frequency plus the phase. And I always like to use this word before my properties, so there you go. And I'm gonna call GL vertex 3D, and in here I'm gonna have D. So for each iteration, give me the Y at that point. And for now I'm gonna put Z here for 0. Okay. Now this formula is in books already. I mean, I haven't made them up, by the way. It's there in books, so in physics and simple math, sinusoidal waves and stuff like that. By the way, you can even have fun, open your old math school books and try to pick up some of the curves in there. Just take one formula and just punch it inside your wave, or punch it inside a for loop, and just generate the vertices and see how the stuff gonna look like. It's actually quite interesting, believe me, and fun to play with for some time. I'm gonna have create here wave, and semicolon. I'm gonna create here a new object of the wave, so new wave, and in my case I'm not gonna use the default constructor. I'm gonna put yes amplitude for 1, frequency I'm going to put it 10,000, and in here I'm gonna put the phase, let it be 1 for now. I'm gonna show you how the phase will affect the drawing. So basically I'm gonna comment the circle wave dot draw wave and control F5 and give it a second, and there you go, we got ourselves a wave. I could rotate it, and as you can see here, it's like woohoo, way beyond. So yeah, I can just simply move it around. So this is actually my frequency. If I minimize the number, let's say to 1000, probably I'm gonna get much smoother effect. Yeah, exactly. So as you can see here, I get much smoother lines because I haven't specified. I mean, D is less than 100, so once this frequency increases, right now the amount of data for drawing, for getting these curves nicely is really minimized. Now a phase, I could just make it like, let's see what's gonna happen if I punch in 100 and give it a second, and there you go, I get much awkward effect. So there you go, once I put the phase to 100 and for a frequency 1000, you get this interesting awkward situation. By the way, I'm moving along the x-axis using the A key in my case, and I'm just simply translating and just pushing the whole thing. If you press Q, Q is apparently, I believe, yes, this is rotation, so there you go, I'm rotating this thing around. So basically you can just have fun with these waveforms. Okay. Okay, so basically in this lesson we have seen how to draw certain points, how to draw lines, how to utilize these ideas in order to draw our own shapes and our own stuff. One more little thing I would like to show you. If I switch from Geo line loop for the circle underscore to triangle underscore fan, if I come over here and hit Control F5, give it a second, you're gonna get actually a full circle. Even if you would like to have fun with it, you could assign interesting colors to it. So I'm gonna have for Geo, for every vertex gonna be created, I'm gonna give it X, Y, and here X plus Y plus 1, for example. So there you go. So I get like, for every X and for every Y, I get a different color. And as you can see here, for every vertex I get really very interesting. Now of course circle, but of course here I got probably some zeros in my colors, so that's why I get black on this side. But if you would like to see it to its full glory, we can go into GL settings and change this clear color to white. Control F5 this one, and there you go. So this is basically a circle. Okay, I'm going to revert back to my nice black background. I'm quite comfortable working with it. So 0, 0, 0. Okay. Now I believe I'm gonna stop right there. I believe it's quite enough for this lesson. And the next lesson we're gonna make the transition, and I'm gonna show you how, for example, to utilize matrices in order to move our objects around, probably make our own first solar system, as well as I'm going to introduce you to GLOT library to draw certain basic 3D objects, or render basic 3D objects. It could be interesting for you guys. Okay, so thanks a lot for your attention, and see you in the next lesson.